Hi guys, let me talk to you about number 2 in section 310 on Achieve. Of course, this is the fantastic related rates section. In this problem, we're just talking about an area an area of a circle that's expanding over time. And we're given in part A in this problem that the radius is increasing at a constant rate of 8 meters per minute when the radius is 51 meters. So you're supposed to find the corresponding change in the area of that circle at that instant in time. So you say, well, if we're going to find the rate of change of the area with respect to time, we need to take the derivative of my area function, which is just pi r squared. I need the derivative of that. Well, the derivative of area with respect to time is just dA dt. I take the derivative of the right-hand side of the equation, and you see the 2 comes down in front, times pi times r, now times the derivative of the radius with respect to time. Keep in mind that 2 came down in front of the r term, and then you had to say times the derivative of the inside, which is where the dr dt comes from. Now we can say, okay, we already know everything to plug into the right-hand side of this equation, so we'll be able to solve for the change in area with respect to time. On the right, I have 2 times pi times r, which I know was 8 meters per minute, times the rate of change of r. The r was 51 meters, and the rate of change of r was my 8 meters per minute. So we have 51 meters times 8 meters per minute. We get 816 pi square meters per minute for that problem after we plug in the r and the dr dt. Of course, order of multiplication doesn't matter. In this case, actually the r is the 51 and the dr dt is the 8, but doesn't matter as far as my answer. Now, the second part of this problem, I can see some that would have a little bit more struggle with. It's giving you some initial criteria here. It's saying that the radius of the circle initially is 0 at a time of 0. So we have to solve for, we're not given what our radius is at the point of interest, we have to solve for it. So it's saying if r is 0 at t equals 0, we're supposed to find the change in the area of the circle at 4 minutes. So we have to assume that the radius is changing at the same constant rate from the very beginning of this problem. So we say, well, the radius is still increasing by 8 meters per minute. In that scenario, we're interested in what the radius is at the point of interest at 4 minutes. So you have to say, well, r evaluated at 4, it would be the initial size of r, which is 0. And then I know the distance of r, distance equals rate times time, so it's growing at a rate of 8 meters per minute for 4 minutes. So we can see, well, okay, the radius is 32 meters at the point of interest. So then I go back to my area formula. We take the derivative of it. dA dt is equal to 2 pi r dr dt. Plug what we know in. 2 times pi times r, we know is 32 meters, times dr dt, the 8 meters per minute. When you plug that into your calculator, you'll get 16 times 32, or 512 square meters per minute. Change in area over change in time, although of course Achieve already does the units for you, so you won't need to plug that part in, but please do keep your answers exact. Those are gorgeous questions.